No, see, this is a grass. This is a grass one. See, you know how you use them, and have you ever made like a fake clock in the primary, and then they put their hands on there? Yeah, this is what they call grass fern. So try this one. Did you try this? See that? Got it? That's the screen. No. Steel screen, yes.
No, that would be this copper.
Which ones work? Those work. Okay. You said the ones on that side don't work?
This, no.
This is a oil wool yarn. Y'all didn't test it. You said it doesn't work.
It works.
This is a steel paper clip.
Is this a paper?
Okay. Yes. The towel trim.
But this is like oil. This aluminum grade. Oil.
Paper fastener. Probably needs a paper clip. That's probably paper clip. See, paper clip. Paper fastener, paper clip. Uh-oh, we got a group already done testing. It's about time to wind it up. We'll give you I'll give you about 3 more minutes.
Come on.
You got them all. The paper fastener, the paper clip. Everything's in that bag, yes.
Where's the river?
She's rolling. She's good. That's it. She's trying to get those 3 minutes. Use those 3 minutes.
This is a big
That's what they call a washer. Yep. You use them when we bake this part.
Skip this.
Okay. 2 groups done. 2 minutes. 2 more minutes. No, you don't need it for that. You need to finish testing your item.
Where's this clip?
Paper faster. How are we done?
What about these sponges? Is this a sponge?
Does it work?
Okay, guys. We got one more minute. One more minute.
What's that? That is still squeezing. That is still squeezing.
We done in this house.
Almost. Concentrate. 30 seconds. 30 seconds.
Did this
30
work?
seconds.
What about one? No.
30 seconds. 15 seconds.
Yes.
15 seconds. Time. Hey, put your pencils down. Put your test items down. Put them all. Yeah, put them all down. Put your eyes back up here. Now, let's look at your predictions. Now, look at your test results. Look at your predictions and look at your test results. What is similar about all of the conductors? Let's see. What's similar about all the conductors, Caesar?
They're all metal.
They're all metals. Let's see if he's right. All metals conduct an electric current. So if any of these objects were metal, then yes, they're going to complete the circuit and make the motor run. And if it was plastic, wood, that's an insulator. It's not going to complete the circuit. Okay, before we go to our next part, let's talk about the foils, okay? In your bags, we had copper foil and we had aluminum foil. Did you find out what did you find out about the foils?
They both work.
They both work. Why do you think that they both work, Caesar? Because they're both what?
Metal.
Metals, yes. Okay? I know a lot of times, some people, I see where some people will say that they didn't think that foils could be conductors because they're too thin and too flexible. But they can be. They are conductors. And they do help pass to make electric current flow. So now, let's look at our circuit. Go back, let's look at our circuit. Just examine your circuit. Take a glance at it. One few little minutes. Few little seconds. Just look at it. Okay? Now, which part of the circuit do you think are insulators? Which part of the circuit makes an insulator, Don?
It's red, but the metal is a
Conductor?
Yeah.
Yeah. Don said, well, he thinks that this wire, the red part, may be an insulator, and the wire part is conductor. He's right. A wire is both an insulator and a conductor. This red part that you see on the wire, it is plastic. And the plastic is, as we found out also by testing plastic, it's an insulator. But when you peel that plastic off, that wire shows. And that wire part is, well, excuse me, the metal part of the wire is an insulator. It'll cause electric current to flow through, okay? Let's see, which part of the circuit do you think is a conductor? We already know what the wire is, but what other parts do you think could be a conductor? Amari.
The switch.
The switch. Why do you think the switch could be a conductor?
Because when you put it towards the metal, the motor starts running.
Right, and then it's got, and plus, if you look on the switch, what's already on her? What's already on the switch? Metal, yes. What's another part of our circuit system that could, of our motor system that could be a conductor other than wires and a switch? Ariel. The battery? Nah, not the battery. Try again though. Which part produces the motion? The energy. No, it's a. What other part do you think could be a conductor, Jeremiah? She just said the batteries, the D cell, the same thing. It's not the battery. Let's try this again. Maybe I'm not saying this correctly. Which parts? We know the parts of our motor system. It's the motor, the switch, the battery, and the wires. We already have the wires as a conductor. We have the switch as a conductor. What other part is a conductor, Summary?
Motor.
Yes, the motor. How do you know the motor is a conductor?
Because it has metal.
Okay, yeah, because of the metal. All right. Now let's look at the switch. If you want the blue person, take your switch off. Take your switch off of your circuit base. Okay? Let's look at the switch. When the switch is open between two metal contacts, what's in between the two metal contacts? If that makes sense. Let me rephrase that. What is between the two metal contacts? Don.
Air.
Air. You can't see it, but we know it's there, right? Okay, I have another question. Is air a conductor or insulator? Is air a conductor or insulator, Mayela? It's an insulator. How do you know it's an insulator?
Because
You
you can't see it.
can't see it, but what happened? What's still happening? You can't see the air, but is anything flowing through there? No. No current flow, but it is an insulator. Good job, Mayela. And an important function, an important part of the function of the components in the circle is that they allow current to flow to some places, but not to others, okay? So remember that, guys. Now, guys, let's dismantle and clean up. I need the blue person to dismantle the blue person, take apart all the pieces on the circuit, and put them back in the bucket. The blue person, put them all back in the circuit. Put all the pieces of the circuit back into your bucket. Yellow person, take your bucket to the back table. little person, could you take the circuit bases to the back? Jose, pick up the bags and take them to the back table. Right, Jose. You got all. Jose's got all the bags. Now let's focus your attention to the board. Focus your attention to the board. Okay, let's do a quick review, guys. All right, what are conductors and what do they do? What are conductors and what do they do? Let me see. Let me get out my bowl. Don, what are conductors and what do they do?
Conductors are things that, conductors are metal pieces and they make, and they're, and they can,
What's that word? Current?
and they make the current flow
In the circuit. He said conductors are materials, aka metals, that they allow the current to flow in the circuit. What are insulators? They're opposite of the conductors. So, somebody tell me what an insulator is. What's an insulator, Jeremiah?
It doesn't
It doesn't allow the current to flow in a circuit. Got it? Does everybody got it? Everybody knows what a conductor is. Allows current to flow. Insulator does not allow the current to flow. Okay? Now, so we can review, we are going to play an interactive game. It's called Conductor Detector. So I'm going to call a few people up. I'm going to pick a few people just straight out of my box, out of my little container. And you're going to come up. I'm going to give you an example. You're going to come up. Don't pick the button. So, that says a cough cover button. And I put it in between the wires. Now, if it will conduct, the motor's going to run. And you're going to see the flag just wave around, okay? So, let's see. Ashton Ford, come up here and try to test an object. Spoon. Is a spoon a conductor?
Yes.
Yes. You see that? You see the motor run? The flag is just waving back and forth. Okay. Now, let me call somebody else. Let's test something else. Jacqueline, come up here and test an object. Miss Howard? Yes. Hey. Okay. I'm videotaping. Okay. All right, bye. So was a nail conductor?
Yes.
Okay, so you see the flag waving. Anastasia. Brass paper faster. All right, is it brass paper faster? We see it works. Okay. Now we can test one more. Mari. Yeah, washer, it worked. All right. So we played our game. Now let's go back to our let's go back to our focus question. I'm gonna come around. This is your exit slip for today. Okay? It's got our focus question on here, and it's got a challenge question on here. You can write, and it says, the focus question, what is needed to make a complete pathway for a current to flow in a circuit? And the thinking challenge, think about the objects around your desk. What object do you think would be a conductor of electricity? Explain your thinking. Okay, guys, say with me, I can, close our lesson now. I can identify what is needed to make a complete pathway for a current to flow in the circuit.
A complete pathway for a current to flow.
What is needed to make a complete pathway for a current to flow in a circuit? What is needed? Okay, so let's start this out. We can restate the question. To make circuit, you will need what's two things we talked about today? What's two new vocabulary? Here we go. Insulate. So would you need one of those to make energy flow through, or would you need insulation? Once you start with the conductor, you will need, okay, to flow in the circuit, you will need a conductor. Is that fine? Okay, so we got this right there. Subscribe. Let's see. It says, think about the object around your desk. What object do you think would be a conductor of electricity? Think of your thankful, or explain your answer. What is a conductor? Your desk, what? Use pointer or? Oh, what do you call the bottom of your desk? Why would this be a conductor? Okay. Got it? Now, you know I always like, I scribe, but I like for you to also rewrite it for yourself, okay? There you go. Got it? What is needed to make the complete pathway for a current to flow in a circuit? You put you will need a conductor. And you will need a conductor. What's that place? Metal, M-E-T, what happened when we use an insulator? Okay, you got conductor, but why do you need both, or do you just need one? Why do you think you need both? You said what it is. It says what is needed to make a complete pathway for a current to flow in a circuit. So it's wanting to know which one is going to make, like, you know how I said what would make in the beginning of the lesson. I said what will make a motor run, and we tested those objects to see which one would make the motor run. Now, did the conductors work or did the insulators work? Alright, so then you don't need an insulator to make it run. You just need a conductor. You understand? You understand? What is needed to make a complete pathway for a current to flow in the circuit? Think about the objects around your desk. What objects do you think would be a conductor of electricity? Explain your thinking. Now, think about the objects around your desk. It can be around or in your desk. Which one do you think will be a conductor of electricity? Yes. Okay, if you're done, give me a thumbs up or raise your hand so I can come get your collect your exit slip. Make sure you got your name on it. Thank you. Thank you. 4/23.